In this lesson, we will discuss another new concept in calculus called antiderivatives. Now, you remember in our last class, we constructed the graph of the derivative of a function if the graph of the function is given. Now, if you look at the graph of a function, we know how the graph of the derivative function will look like. Now, in this lesson, we are going to look at the derivative and see if we can construct the function using the derivative. Remember, derivative is the study of change and rate of change. And if you know the change or the rate of change of a function, can you construct the function? Can you add up all those changes to construct the function? In other words, the antiderivative is actually the reverse process, the opposite process of finding the derivative. In other words, if you are given the derivative, can you find the position, the function from the derivative? So, we say f of x is called the antiderivative of f prime x. In other words, f prime x is the derivative of the function f of x. So far, we were using f of x to find the derivative f prime x. In this lesson, we will have f prime x. We will have to use f prime x to find f of x. So, if f prime x is called the derivative of f of x, then f of x is called the antiderivative of f prime x. Now, another way of saying, y is the antiderivative of dy by dx. What does dy by dx stands for? Dy by dx is the derivative of y with respect to x. I want you to understand here, x is the independent variable and y is the dependent variable. And the dependent variable is our function. So, dy by dx is the rate of change of y with respect to x. If you can now add, somehow sum up, you see, the antiderivative is a process of summing all these changes to get your function back. And that is the process of taking the antiderivative. So what is the antiderivative of dy by dx? The antiderivative of dy by dx is the function y. The antiderivative of dp by dt is the function p. In other words, the antiderivative is the dependent variable that can be solved from the given derivative function. That's right. So, in that case, if dx by dt is the derivative of x with respect to t, then x is the antiderivative of dx by dt. So, in this lesson, if we know dx by dt, we will then be able to find x. If we know dy by dx, then we will be able to find y. The antiderivative of a function is called the integral of the function. The integral, or the process of finding the antiderivative, is called integrating the function. Right? The process is called integration. The operation of finding the integral of a function. Now remember, integral of a function is the antiderivative of the derivative function. And the process is called integration. And we use a symbol for this operation. For any mathematical operation, there is a symbol. Is that right? Now, d by dt stands for derivative of the function with respect to t. d by dx stands for derivative of the function with respect to x. Similarly, we have a symbol for integration. Look at this. It is an s which is stretched. If you stretch an s, that is the symbol for integration. In other words, integration is actually the process of summing all the changes, all the rates of changes to get the function back. You see, the derivative, or the process of finding the derivative, is called differentiation. Differentiation is the process of finding the rate of change. Now, in other words, we have to break the function down into small changes. In the opposite process, we add up all these changes to get our function back. In other words, sum of all the derivatives, sum of all the changes. And therefore, the symbol used for the process, the operation of integration, is an elongated S. Now look at this. You read it like this: integral 2 dx. Now this dx is an important factor. Now look at what that stands for. Stands for integrate 2 with respect to x. In other words, this indicates that the independent variable is x. So integral 2 dx stands for integrate 2 with respect to x. Integral p dt stands for integrate the quantity p with respect to t. That's right. Look at this. Integral x squared dx stands for integrate the quantity x squared with respect to x. Alright, once you remember and know the fundamentals, we can now use this to do basic integration. Now, we already said integrating a function is opposite to the process of finding its derivative. Now, for example, d by dx of 2x equal to 2. The derivative of 2x with respect to x is 2. That means if you integrate 2 with respect to x, you must get back 2x. Because the integration is the process of summing all the rates of change to get your original function back. This is your original function, y equal to 2x. If you find the derivative of that with respect to x, you get derivative of 2x with respect to x is 2. If you now integrate this, in other words, sum all those changes with respect to x, you must get 2x. So we say integral of 2x, integral of the quantity, integral of this with respect to x, integral 2x must give you back the original function. Well, you know that the derivative of a constant is 0. Therefore, what is integral of 0? If derivative of a constant is 0, then if you integrate 0, you must get your constant. Is that right? So, integral 0 dx equal to c. Now, that means we are going to have a problem in this process of integration, because remember, the derivative of 2x is 2. The derivative of 2x plus 5 is also 2. So, if you integrate 2, you might get 2x. You could also get 2x plus 2, 2x plus 3, and so on. That constant number will not be seen when you integrate. Why don't you see the constant number when you integrate? Because when you differentiate it, you understand the meaning of differentiated? When you found the derivative of that constant became 0. So that constant will not appear in the derivative, because the derivative of a constant is 0. And so, when you integrate, because of this process, when you integrate a quantity, you will always add a constant to the result. We don't know what the constant is. It may be 2, 0, 1, any number. That's right. So look at this. Derivative of 2x plus c equal to 2. the derivative of 2x equal to 2, the derivative of 2x plus c also equal to 2. So if you integrate this 2, what should you get back? If you integrate this 2, you must get 2x plus c. Now in this case that c is 0, but it may not be 0 in all cases, and therefore we will follow this rule. Integral of 2 dx equal to 2x plus c. When you integrate any quantity, you always add a c to that, a constant to that. Why do you have to do that? Because the derivative of a constant is 0, and therefore when you find the derivative, the c disappears. And when you find the integral, when you do the opposite process, you must get that c from somewhere. So when you do the integration, always add a 0. Integral a dx equal to ax plus c. Look at that. Integral 2 dx is 2x. And of course you've got to add a c. Integral 2 dx is 2x plus c. Similarly, integral 5 dx is 5x plus c. Integral 3 dt is 3t plus c. In general, integral a dx is ax plus c, an important result. Integral v dt, here v is a constant, it's a number, is vt plus c. This time the independent variable is t. Integral v dt is vt plus c. Alright, remember, the process of integration is opposite to the process of finding the derivative. In other words, if you integrate the derivative, you must get your original function. So tell me, derivative of sine x with respect to x is cosine x. And therefore, if you find the integral of cos x with respect to x, what should you get? If you integrate cosine x with respect to x, you must get sine x. Well, and also you need to add a constant. Why? Because the derivative of sine x plus 5 is cos x. The derivative of sine x plus 10 is also cos x. So we don't know whether in the original function there is a constant or not. To make sure that we don't make a mistake, when you integrate, always add a constant. So integrating cos x with respect to x will give you sine x plus c. These are results you need to remember. Integral a dx is ax plus c. Integral v dt is vt plus c. Integral cos x dx is sine x plus c. Alright, let's do a couple more. The derivative of cos x with respect to x is negative sine x. Is that right? And therefore tell me, if you integrate sine x with respect to x, what will be the result? Well, integral of sine x dx is negative cos x plus c. Because the derivative of cos x is negative sine x, the integral of sine x will be negative cos x plus c. The derivative of tan x with respect to x is secant squared x. Therefore, if you integrate secant squared x, you must get tan x plus c. Always remember, when you integrate a quantity, add a c to it, add a constant to it. And these are some of the basic integration rules that we will be using as we move on. Alright, we had a power rule for finding the derivatives, is that right? Tell me, what is the power rule for finding the derivative? If y equal to ax to the power of n, then dy by dx is an x to the power of n minus 1. Well, we have a similar rule for finding the antiderivatives or finding the integral. Now, in other words, the power rule will be opposite to the power rule of the derivative. So you can imagine how the power rule is going to look like. The power rule for the integration is integral x to the power of n dx. In other words, x to the power of n is integrated with respect to x will give you x to the power of n plus 1 over n plus 1 plus c. Now, you can do you can find the derivative of this. If you find the derivative of this, you must get x to the power of n. Is that right? Now, what is the derivative of this quantity? If you find the derivative of the numerator, it will be, this is 1 times n plus 1 times x to the power of n plus 1 minus 1. N plus 1 minus 1 is n. And the n plus 1 here will cancel this n plus 1. You'll be left with an x to the power of n. And the derivative of a constant is 0. So, the derivative of this is x to the power of n. And therefore, if you integrate x to the power of n with respect to x, you must get this. X to the power of n plus 1 over n plus 1 plus c. Alright? Write this down a couple of times. The integral of x to the power of n dx equal to x to the power of n plus 1 over n plus 1 plus c. Okay, can you do this in your mind now? What is integral of x squared dx? Integral of x squared dx is x to the power of 2 plus 1 over 2 plus 1 plus c. It will be x cubed over 3 plus c. Very simple rule. That's right, here it is. Integral x squared dx is x to the power of 2 plus 1 over 2 plus 1 is x cubed over 3 plus c. Remember, we have integrated x squared dx to get this. That means if you find the derivative of this, you must get x squared. Can you check it on your own? The derivative of x cubed is 3x squared. 3 and 3 will cancel. The derivative of c is 0. So the derivative of this quantity will be x squared. Integral x squared dx is x cubed over 3 plus c. The derivative of x cubed over 3 plus c is x squared. Okay, so practice the power rule for integration. How about this? Integrate 2 over x squared dx. Now remember, any quantity you want to integrate using the power rule, you must write it in the form, the general form, x to the power of n dx. Now, this will be 2 times 1 over x squared dx, is that right? And that x squared on the denominator can be brought to the numerator using a negative power. So this will be integral 2 x to the power of negative 2 dx. Now one thing you must always know and practice, whenever you want to integrate a quantity, and if that quantity is multiplied by a constant, you can take that constant and put it outside the integration sign. So this is actually the same as 2 times integral x to the power of negative 2 dx. Always practice this. Remove the constant and take it out of the integration because the constant will not change. Now, use the power rule to integrate x to the power of negative 2 dx. Integral x to the power of n dx is x to the power of n plus 1 over n plus 1 plus c. So this will be x to the power of negative 2 plus 1 divided by negative 2 plus 1 plus c. There you go. So that 2 there, 2 times x to the power of negative 2 plus 1 over negative 2 plus 1 plus c. What is that equal to? That will be 2 times x to the power of negative 2 plus 1 is negative 1, and the denominator is negative 1. Now, there are 2 things that you need to do here to simplify. One is this negative 1 make the whole quantity negative. So I can remove that negative 1 and write this as negative 2, right? And then x to the power of negative 1, we need to write it using a positive power, which means you need to bring it down to the denominator. It will be x to the power of positive 1. So this will be, these 2 combined will be negative 2 on the numerator and x on the denominator. So that will be negative 2 over x plus c is the result of integrating 2 over x squared. Okay, let's move on and use the power rule for integration for a couple of other examples. Integrate 5t plus 6 dt. You can see there are 2 terms in there. So, what do? We integrate each term, just like we did in finding the derivatives. Take each term and find the derivative. Similarly, here, take each term and integrate it. This will be integral 5t dt plus integral 6 dt. Now, what is integral of 5t dt? This one can be 5 comes out 5 times. Integral of t dt, the power of t is 1. So integrating that will give you t to the power of 1 plus 1 over 1 plus 1. Plus, integrating 6 dt will give you 6t. Didn't we talk about in the beginning? Integral a dt is at plus c. That's right. In fact, integral of dt equal to t. Integral of dx equal to x, and so on. Now tell me, we have 2 terms that we integrated, but we used only one constant. Why? Should we use a constant for each term? Now remember, constant is a number. So if I use one constant here and another constant for the second term, if you add those 2 constants, it will still be another constant. So we need only use one constant, which takes care of the constant in each case. So what is the result? That will be 5t squared over 2 plus 6t plus c, and that is the result of integrating this. Which means if you find the derivative of this quantity, it must be 5t over 6. Is that right? Try that on your own. Another one. Integral x times x squared plus x dx. Well, this one, in order to bring it to the general form that is here, x to the power of n dx, first we distribute that x. And that will give you integral x cubed plus x squared dx. And now we can integrate each term. Is that right? So split that into 2 integrals. That will be integral x cubed dx plus integral x squared dx. Can you do this in your mind? Integral x cubed dx. Look at the power rule. Integral x to the power of n dx is x to the power of n plus 1 over n plus 1 plus c. So this will be x to the power of 3 plus 1 over 3 plus 1. There you are. That will be x to the power of 3 plus 1 over 3 plus 1 plus integral x squared dx is x to the power of 2 plus 1 over 2 plus 1 plus c. We need only add 1 c after integrating all the terms. And that will be x to the power of 4 over 4 plus x cubed over 3 plus c. Okay, let's move on and do another one. Integrate square root x plus 1 over 2 square root x. Well, what will you do to integrate this? Remember, you need to reduce each term in the power rule form, x to the power of n dx, in order to integrate. That means we're going to write it like this. Square root of x is x to the power of 1/2, and 1 over 2 square root x is 1 over 2x to the power of 1/2. Now, is this sufficient in order to integrate? No, because we don't know how to integrate a function with x sitting on the denominator. We can only integrate where x is on the numerator. So we need to bring this x to the power of 1/2 to the numerator. What will that become? It will become x to the power of -1/2. So this will be x to the power of -1/2 divided by 2. That 2 will remain on the denominator. So it will be integral x to the power of 1/2 plus 1/2. This 1/2 is taking care of that too. 1/2 x to the power of -1/2. X to the power of positive 1/2 goes to the numerator, become x to the power of -1/2 dx. And now you can integrate it using the power rule. Tell me, what will be the integral of x to the power of 1/2? It will be x to the power of 1/2 plus 1 over 1/2 plus 1. And integral of x to the power of -1/2 will be x to the power of -1/2 plus 1 over -1/2 plus 1. And there you are. Integral x to the power of 1/2 is x to the power of 1/2 plus 1 over 1/2 plus 1 plus 1/2 times, that's a constant, so 1/2 times. Integrate x to the power of -1/2, that will be x to the power of -1/2 plus 1 over -1/2 plus 1. Can you do this addition in your mind? What is 1/2 plus 1? That will be 3 over 2. So this will be x to the power of 3 over 2 divided by 3 over 2. There you go. X to the power of 3 over 2 divided by 3 over 2 plus 1/2 times -1/2 plus 1 is positive 1/2. 1 minus 1/2. So that will be x to the power of 1/2 over, this is also 1 minus 1/2, which is 1/2. Now how to simplify this? If you notice, you are dividing x to the power of 3 over 2 by 3 over 2. Dividing by 3 over 2 is the same as multiplying by 2/3. So this 2 is going to go on the numerator, and this 3 is going to stay on the denominator. It's nice to practice that. So x to the power of 3 over 2 divided by 3 over 2 means multiplied by 2 over 3. The 2 will go to the numerator and 3 will remain on the denominator. And here, if you notice, there is a 2 here on the denominator, and that is multiplied by 1/2, and these 2's will cancel. Or you can also think like this: dividing by 1/2 is multiplying by 2 over 1. The 2 goes up there and cancel with the 2. Whatever way you want to cancel it. So this 2 and that 2 will cancel, giving us this 2 goes up, gives me 2x to the power of 3 over 2 over 3 on the denominator, and x to the power of 1/2. Now, this is a rather shabby way of leaving an answer. Now, the best way will be to try and factor out. Now, can you tell me what is common in these two terms? You must understand x to the power of 3 over 2 can be written as x to the power of 1 times x to the power of 1/2. Is that right? Because x to the power of 1 times x to the power of 1/2 is x to the power of 1 plus 1/2. So this is the same as x to the power of 1 times x to the power of 1/2. That means I have an x to the power of 1/2 common there. And I have shown you how it is written there. Now I have this 2 taken separate, and this 3 on the denominator I wrote 1/3. I hope you're following here. This 2 times 1/3, and this x to the power of 3 over 2 is written as x to the power of 1/2 times x. Is that right? When the bases are the same, you add the exponents. This will be 1/2 plus 1, 3 over 2. Plus, now look at the way I manipulate the second term. I wrote the second term also as 3 times 1/3. Why did I do that? 3 times 1/3 is 1. Actually, I did a manipulation here so that I create a 1/3 common in both these terms. That's the reason why I did that. Now, in doing that, I have a 1/3 x to the power of 1/2, a 1/3 x to the power of 1/2 common in both. I hope you follow this. Now, in this term, there is the coefficient is 1, but I manipulated that as 3 times 1/3 in order to create a 1/3 here so that 1/3 can be factored out. All right, now let's factor out the common terms. What are the common terms we can factor out? 1/3 x to the power of 1/2. So that comes out, leaving 2x in the first term plus 3 in the second term. Now look at this. This is a much better and a much cleaner way of writing the result than this. But you can also do one more thing. If you look at the original expression, you can see square root of x. 1 over 2 square root of x. So this x to the power of 1/2 needs to be put back in that form. So what is x to the power of 1/2? Is square root of x. So the final answer is square root x over 3 times 2x plus 3 plus c. And that is the final result. Now I want you to work this out on your own a couple of times. Now, in most cases I have seen students follow the calculus part. In other words, finding the derivatives and antiderivatives fairly easily. But when it comes to the algebra of simplification, most of you stumble. Now, you need to have practice. So practice some of these on your own. Write them down on your own and learn the process of simplification. All right, another one. Integrate t squared minus sine t dt. All right, we have two terms. We integrate them separately. So that will be integral t squared dt minus integral sine t dt. And you know how to integrate both these terms. How do you integrate t squared dt? It will be t to the power of 2 plus 1 over 2 plus 1. So it is t to the power of 2 plus 1 over 2 plus 1 minus, don't mess up the signs there, minus, what is integral of sine t with respect to t? Is negative cosine t. So that would be minus negative cos t plus c. Don't forget, you need to add a constant when you do your integration. Now, in the next step, write it as t cubed over 3 minus become plus. So that will be t cubed over 3 plus cos t plus c. Okay. Now, another new concept. We are now going to look at what's called a differential equation. What is a differential equation? A differential equation is an equation that contains the derivative of a function. But when you say function, I want you to think of it as the dependent variable. You see, a function always has an independent variable and a dependent variable. The dependent variable is actually the function y equal to 2x squared plus 3. That x is the independent variable, y is the dependent variable. Now look at this equation. dr by d theta equal to pi. What does that mean? It means the derivative of the function r with respect to theta. It gives you several information. It tells you that r is a function of theta. Theta is the independent variable, r is the dependent variable. Just like dy by dx. dy by dx is the derivative of y with respect to x. X is the independent variable, y is the dependent variable. So here, r is the dependent variable, which is the function. We say r is a function of theta. And dr by d theta equal to pi. This is a differential equation. Why is it a differential equation? Because it contains the derivative of a function with respect to its independent variable. The function is r, the independent variable is theta. dr by d theta is the derivative of r with respect to theta. Because this is the derivative of a function, the equation that contains that is called a differential equation. So we are told that dr by d theta equal to pi. We are also told one more thing. We are given an information. Now look at that. R of 2 over pi equal to 1. We are told that the value of this function r when theta equal to 2 over pi is 1. You see, that information will help us to find the value of that elusive constant. You see that every integration comes with a constant? And in order to find the identity of that constant, we need some information like this. I will show you how that is done. Now tell me, what is the meaning of solving a differential equation? The meaning of solving a differential equation is finding the form of the dependent variable. In other words, here the dependent variable is r. That means we need to solve for r. That's the meaning of solving a differential equation. Theta here is the independent variable and r is the dependent variable. By solving the differential equation, we need to obtain what a function r of theta. We need to solve for r as a function of theta. That is the task of solving a differential equation. So what are we given? We are given dr by d theta equal to pi. What we need to do in this case is multiply both sides by d theta. In all these cases, we must write the equation in such a way that one side of the equation will contain one variable and the other side will contain the other variable. That is your task. So that can be done by multiplying the left-hand side and right-hand side by d theta. Now look at that. We have dr equal to pi d theta. Now the left-hand side has got dr and the right-hand side got d theta. Now remember, dr means 1 dr, isn't it? And now we can integrate both sides. You see, integration is a mathematical operation. If you have an equation like this, if you do a mathematical operation on the left side, you do the same thing on the right without changing the equation. That is the beauty of a mathematical equation. So we do the operation of integration on both sides. So we say integrate both sides. Do the operation of integration on both sides. It will then give you integral dr equal to integral pi d theta. Well, you know that integral of 1 dx equal to x. Integral of 2 dx equal to x. Integral of 1 dr must be equal to r. Integral of dr equal to r. That's right. And integral of d theta must be equal to theta. See, pi is a number. So integral of 2 d theta is 2 theta. Integral of pi d theta is pi theta. Alright. So what we get is integrating dr will give you r. Integrating pi d theta will give you pi theta. Of course, you got to add a constant. Now, you must write it like this. R is now a function of theta. So you got to say r of theta equal to pi theta plus c. Now, you see, we need to find the value of c in order that the solution for r become meaningful. Now, in order to find the value of c, we use that given information. What is the given information? The given information is the value of r when theta equal to 2 over pi equal to 1. That's what it means. R of 2 over pi equal to 1 means when theta equal to 2 over pi, r equal to 1. So let's go to this equation. Replace r by 1 and then theta will be 2 over pi. We get 1 equal to pi times theta is 2 over pi plus c, and you can see the pi and pi will cancel, and that will give you c equal to is it -1 or 1? What do you think? So when pi and pi cancels, we get 1 equal to 2 plus c, and you solve it, you get c equal to -1. And therefore, what is the solution of this equation? Because the solution is r of theta, r as a function of theta is pi theta plus c, c is -1. So this is the solution of this differential equation. It's a beautiful way to solve simple differential equations. You see, a lot of phenomenon around us can be actually described by simple differential equations like this. And solving differential equations can get a lot of information. Okay, now in the lesson on derivative, we talked about how the concept of derivative can be used in solving problems in moving objects. The problems involving position, velocity, acceleration. Now the same can be used here. All right, listen carefully. We said in that class that velocity is the derivative of the position function. In other words, the speed is the rate at which distance is traveled. Is that right? Now, when you make it more concrete, we say velocity is the rate of change of position of an object. So velocity is the derivative of the position function. Acceleration is the derivative of the velocity function. Now, in this lesson, we think the other way around. If you have acceleration, since velocity is the derivative, since acceleration is the derivative of velocity, if you integrate acceleration, you must get velocity. Similarly, since velocity is the derivative of displacement, displacement is actually a position function. Velocity is the derivative of the position function. Integrating velocity should give you the position function. So, once again, in the last class we talked about if you have a position function, you can find the velocity function as its derivative. If you know the velocity function, you can find the acceleration function as the derivative of the velocity function. Now in this lesson we go back. If you have acceleration, if you integrate acceleration, you get velocity function. If you integrate velocity function, you get the position function. All right. Velocity v of t is the derivative of the position function x of t. That means v of t equal to dx over dt. That's the information we had in the last lesson. Therefore, position function x of t can be obtained by integrating the velocity function. Therefore, x of t equal to integral v of t dt. Alright? Similarly, acceleration a of t is the derivative of the velocity function v of t. A of t is dv over dt. That means velocity v of t can be obtained by integrating the acceleration a of t, or v of t equal to integral a of t dt. Well, I hope you understand that concept fairly well. You need to understand that concept in order to do problems. That means if you know the acceleration of a moving object, then actually if you know the acceleration, then you can find the velocity function. And if you know the velocity function, then you can find the position function using the method of integration. Now, in order to do that, you remember when you integrate, for example, when you integrate the acceleration, you get the velocity function. But the process of integration will introduce a constant. In order that the velocity function that we obtain by integrating the acceleration may be useful, we need to know what that constant number is. And how do you know that? Well, if we know the initial position x0 and the initial velocity v0, those will help us to find the value of that constant. Well, we will see how that is done in a problem like this. An object starts from rest. Well, I know you are not physics students, but these are problems from our everyday life. An object starts from rest. Now here I have a ball, it is at rest, and it starts moving. It means its initial velocity is 0. So if an object starts from rest, its initial velocity is 0. What does that mean? When t equal to 0, the velocity equal to 0. That's the meaning of that. So an object starts from rest at x equal to 2 meter and accelerates uniformly at 2 meters per second squared. This is the acceleration. Now, it is at x equal to 2 means when you look at it initially, when t equal to 0, its position is 2 meters. So you have actually two information in this problem. At t equal to 0, the velocity is 0, and at t equal to 0, the position is 2 meters. Then say, find the velocity of the object at t equal to 5 seconds. What is the position of the object at that time? Okay, let's put down the given data. What do we know? An object starts from rest means that its initial velocity is 0. Initial velocity means when t equal to 0, the velocity is 0. So we write it like this, v0 equal to 0. That's right. And it starts at x equal to 2 means its initial position is 2 meters. Initial position means the position at t equal to 0, or it means x of 0 equal to 2. Those are two important information. What other information do we have? We know that its acceleration is 2 meters per second squared. Now, if you know the acceleration, we can find the velocity function. How? By integrating it. That's right. We have acceleration is 2 meters per second squared. So, velocity function v of t can be obtained by integrating the acceleration function a of t. So if you integrate this, you will get the velocity function. So look at that. V of t is integral a of t dt, and our a of t is 2 meters per second squared. We're going to drop the unit and just take the number. So that will be integral 2 dt. What's integral 2 dt? Integral 2 dt is 2t plus c. That's right. So what we have is v of t equal to 2t plus c1. I call it c1 because in the process of solving this problem, there will be another place where we have another constant. So we call this a c1. Is there any way to find the c1? Yes. How? We are told that the value of this velocity when this t is 0 is 0. So v0 equal to 0 means when you replace your t by 0, the value of this velocity will be 0. So to find the constant c1, we use the condition v0 equal to 0, and that tells me when this t equals 0, 2t is 0, and at that time the velocity is 0. We get 0 equal to 0 plus c1, or the value of that c1 is 0. Well, so we settle there, we have no worry. Alright, so what is the velocity function now? Our velocity function is v of t equal to 2t. Now, we need to find the velocity of the object at t equal to 5 seconds. So if v of t equal to 2t, what is v of 5? V of 5 is 2 times 5, that is 10 meters per second. Now look at the neat way we can solve problems in physics. So when you move into taking physics, you will find these kind of problems very simple. Alright, now we have v of t equal to 2t, and also we know that when t equal to 0, the position is 2 meters. Now, position x of t can be obtained by integrating the velocity function. In other words, x of t equal to integral v of t dt. Well, v of t is this 2t, and that is integral 2t dt is our position function. Can you integrate that? Integral 2t dt? Well, 2 is a constant, that will remain. Integral t dt is t to the power of 1 plus 1 over 1 plus 1. So integral t dt is t squared over 2 plus a constant c2. So what's our position function again? X of t is t squared plus c2 because these 2's will cancel. Now we need to find the c2. How do you find the c2? We know that this x is 2 meters when this t is 0. That's the meaning of this x of 0 equal to 2. When t equal to 0, x equal to 2. So we will say 2 equal to 0, this is 0, plus c2, and that gives you the value of c2 equal to 2. And therefore, what is the position function now? Therefore, x of t is t squared plus 2 is the position function. You can now use this position function to find the position of the object at any given time. Now, we were told to find the position at the time t equal to 5 seconds. Therefore, x of 5 is 5 squared plus 2, that is 27 meters. So the object started at x equal to 2 meters, and at the end of 5th second, it is at 27 meters, and we also calculated its velocity at that time. A very neat way. You see, calculus is actually a tool to solve problems that we confront in the world. In fact, most of the problems that we solve about the universe is actually solved using the method of calculus. Another one. A ball is dropped from a height of 100 meters and it accelerates uniformly at negative 9.8 meter per second squared. A ball is dropped from a height of 100 meters. So that means the initial position of the ball is 100 meters. Is that right? Because we take the origin at the ground. We are holding the ball at a height 100 meter means the position. This time, because the ball is moving vertically, we use Y for the position. When the objects move horizontally, we use X for the position. When vertical motion is considered, we use Y for the position. All right, what do we need to find? How long does it take for the object to fall to the ground? You see, how long will it take for the position to become 0? When it falls to the ground, its position will be 0. You understand that? Initially, the object is at Y equal to 100 meters. And when you drop it, it falls, and we need to find the time taken for that Y to become 0. That is the problem. Okay. The ball is at Y equal to 100 meters at T equal to 0. So we say Y of 0 is 100 meters. Now here's the ball placed at a height of 100 meters, and this is the origin, which is Y equal to 0. Since the ball is dropped, we said the ball is dropped. What is its initial velocity? Well, initial velocity is 0 because it is dropped. Nobody used any force to throw it down. So we say initial velocity V0 equal to 0. So we know Y0 is 100 meters, V0 is 0. Okay. And we know the acceleration function. Acceleration is negative 9.8 meter per second squared. Now you might be wondering how I write the unit. Look at that. Meter per second squared. Second squared is in the denominator. Now, the standard form is don't leave a unit on the denominator. Second squared on the denominator is second to the power of negative 2. So read it as meter per second squared. Meter times second to the power of negative 2. All right. Velocity v of t is obtained by integrating the acceleration function. So we get v of t is integral a of t dt, and a of t is negative 9.8. So let's replace that. That will be integral negative 9.8 dt. Can you integrate that? Integral a dt is a. Integral a dt is at plus c. Is that right? Integral negative 9.8 dt will be negative 9.8 t plus c1. c1 is our first constant. Now, how do you find this c1? Well, we can find the c1 because you know the velocity at a given time. There you go. When t equal to 0, when this t equal to 0, the v is 0. Therefore, we say 0 equal to 0 plus c1. I hope you understand here. When you replace this t by 0, this will become 0. And at that time, the value of velocity is 0. That's why it becomes 0 equal to 0 plus c1. And what is therefore the value of c1? c1 is 0. So our velocity function is now v of t is negative 9.8 t. That's right. All right, we got the velocity function negative 9.8 t. And also we know that at t equal to 0, the position of the ball is 100 meters. And now we take the velocity function, integrate it to find the position function. All right? Y of t is integral v of t dt. And replace this v of t by this negative 9.8t. So that will be integral negative 9.8 t dt. Can you integrate this? This negative 9.8 is a constant, so that will not change. If you integrate t dt, it will be t squared over 2. T to the power of 1 plus 1 over 1 plus 1. So this will be negative 9.8 times t squared over 2. There you are. Negative 9.8 t squared over 2 plus a constant c2. So our function is y of t equal to negative 9.8 t squared over 2 plus c2. How do you find the c2? Well, using that situation given to us. What is that situation? That situation tells us that when this t is 0, you replace this t by 0, then the position is 100 meters. When t equal to 0, y equal to 100. So we can write 100 equal to 0, this will become 0, plus c2. That's right. Now I simplified this. You see, 9.8 divided by 2 is 4.9. So this is negative 4.9 t squared plus c2. And now we know that when this t is 0, y is 100. Use that. We get 100 equal to 0. This becomes 0 because when you replace y by 100, you need to replace t by 0. And that gives you c2 equal to 100. And take this c2 into here, we will get the position function. So we got y of t is negative 4.9 t squared plus 100. This is the position function. But how do we answer our question? Our question is, what is the time taken by the ball to fall to the ground? When the ball falls to the ground, what is the value of this y? Y will be equal to 0. In other words, the time taken by the ball to fall to the ground is the time taken for this y to become 0. So all we need to do is set this equation equal to 0 and solve for t, which actually you can do on your own. So when the ball falls on the ground, y equal to 0. So we say 0 equal to 4.9 t squared. Well, negative, that must be negative there. Negative 4.9 t squared plus 100. Or 4.9 t squared equal to 100. That gives you t equal to 4.5 seconds. Well, it will give you two values of t, one positive, one negative. You don't need the negative values for time. So this is the time the ball will fall to the ground in 4.5 seconds. Again, look at that, how neatly we can use the method of calculus to solve fairly complex problems in moving objects. All right, another one. This time, you see, in the last problem we dropped a ball from a certain height. In this one, we throw a ball vertically up with an initial velocity of 25 meters per second. If it has a constant acceleration of negative 9.8 meters per second squared, how long does it take to reach the maximum height? What is the maximum height? Okay, this time you are at the origin. Your initial position is 0. Y0 is 0. But you have an initial velocity. You stand at the origin and throw the ball up with a certain velocity. What is that velocity? 25 meters per second. All right, let's put this down. The ball is at y equal to 0 at t equal to 0. You are standing at the origin and ready to throw the ball up. That means at t equal to 0, the ball is at y equal to 0. So we have y0 equal to 0. position y at time t equals 0 is 0. And also we know we threw the ball with this velocity. That means when you start the clock at t equals 0, the ball has a velocity. That's the only way you can actually throw something out. You got to give it an initial velocity. So v0 is 25 meters per second. That's right, this ball is given an upward velocity. So, as usual, we take the acceleration, integrate it to find the velocity function. V of t equal to integral a of t dt. A of t is negative 9.8. So we got integral negative 9.8 dt will be negative 9.8 t plus c. There you go. And now we need to find the c1. How do you find c1? c1 can be found using this condition. When t equal to 0, when you replace this t by 0, then your v will be 25. So when this term becomes 0, the value of v will be 25. That's right. So we have 25 equal to 0 plus c1. That gives you c1 equal to 25. Therefore, what is our velocity function? V of t, therefore, is negative 9.8 t plus, in place of c1, we now write 25. That's our velocity function. Now, if you integrate the velocity function, you can get the position function. All right? Well, before we do that, in this question, we need to find how long does it take to reach the maximum height. Now tell me, if you throw a ball up with a certain velocity, say up with a certain velocity, can you see it? Now, when it reaches the maximum height, it stops. So what is the velocity when the ball reaches the maximum height? At the maximum height, its velocity is 0. It goes up and stops and then returns. Is that right? So we say when the ball reaches its maximum height, its velocity v equal to 0. So what we can do is we can go to the velocity function and put the velocity equal to 0 and solve for t. It will give you the time taken by the ball to reach the maximum height. Is that right? Yes. What is the time taken for the velocity to become 0? The time taken for the velocity to become 0 is the time taken by the ball to reach the maximum height. That's right. Okay. So we would say 0 equal to negative 9.8 t plus 25 and solve for t from there, t equal to 2.55 seconds. It means in 2.55 seconds, the velocity, see as you throw it up, the velocity initially is 25 meters per second. The velocity will decrease, 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 become 0 there. And the time taken for that is 2.55 seconds. And then we also need to find what is the maximum height. In other words, what is the position y when t equal to 2.55 seconds? That is the question. So, we now have the velocity function. We have the time taken by the ball to reach the maximum height is 2.55 seconds. By using the velocity function, we can obtain the position function. How? Integrate the velocity function. Y of t is integral v of t dt, and v of t dt is negative 9.8 t plus 25. So we replace v of t by this. That will be integral negative 9.8 t plus 25 dt. Now here we need to integrate each term, right? Now integrating the first term gives you negative 9.8 t squared over 2 plus integral of 25 dt is 25t plus c2. And negative 9.8 divided by 2 is negative 4.9. So your position function is negative 4.9 t squared plus 25t plus c2. Well, in order that this position function may be useful to us, we need to know what that constant value c is. Okay, so what do you do that? We can do that from this condition. We know that when this t equal to 0, where is the object? The object, the ball, is at the origin. So y0 equal to 0. When you replace t in the equation by 0, y will be equal to 0. That will be 0 equal to, what's my pointer? This y becomes 0 when t in the equation becomes 0. That means this will become 0, that will become 0. That means what is the value of c2? c2 is 0. Therefore, what is our position function? Our position function, therefore, is y of t equal to negative 4.9 t squared plus 25t plus c2. Oh, well, c2 is 0, so this is not there. All right, just cut it off. Our position function is y of t is negative 4.9 t squared plus 25t. And now, once you know the position function, what we need to find is what is the maximum height. What does that mean? It means what is the value of y when the ball is at the maximum height. You know that the time taken by the ball to reach the maximum height is 2.55 seconds. So what all we need to do is find y of 2.55 seconds. What is the value of y at this time? Maximum height is y of 2.55, and that will be negative 4.9 t squared plus negative 4.9 times 2.55 squared plus 25 times 2.55. There, I have done it for you. So y of 2.55 is negative 4.9 t squared, that is 2.55 squared, plus 25 times 2.5, plus, of course, c2 is 0. We have shown that c2 is 0. So that will be 31.9 meter. All right, try and do this problem on your own one more time. And once again, here is a differential equation. We say solve the differential equation. Look at this time. dp over dt equal to k square root of t. Now tell me, what is the independent variable here? The independent variable is t. What is the dependent variable here? That is p. So, in solving the differential equation, what are we solving for? We are solving for the dependent variable p. There you are. And we are given some of these values. What does that mean? P of 0 equal to 500. It means the value of p when t equal to 0 is 500. P of 1 equal to 600. The value of p when t equal to 1 is 600. That's what it means. Find p of 7. Find the value of p when t equal to 7. That is the meaning of this problem. Alright, now how do we start it? When we first did a differential equation, I told you, you got an independent variable and dependent variable. Write the equation in such a way that they will appear on either side of the equation, not together on one side, but one variable on the left and the other variable on the other side. This is called separation of variables. Separate the variables on either side of the equation. So that can be done by multiplying both sides by dt. So multiply by dt both sides. What do we have? Multiply left hand side by dt will give you dp. Right hand side by dt gives you k square root t times dt. Look at that form now. dp equal to k square root t dt. K is a constant. It's a number, we don't know what it is, but these conditions given to us will help us to find that k. Alright, let's try that. Now we need to find the function p as a function of t. What do we do? Now write this as k times square root t is t to the power of 1/2. So what we have is dp equal to k t to the power of 1/2 dt. Integrate both sides. Integral of dp, that's the left hand side, is integral of k t to the power of 1/2 dt. Tell me, what is integral of dp? Integral of 1 dp is p. So we get p equal to, k is a constant that we can bring it out of the integral. So that will be k times integral t to the power of 1/2 dt. Watch it. Is t to the power of 1/2 plus 1 over 1/2 plus 1. That is t to the power of 3 over 2 over 3 over 2 plus c. Okay. So simplify that. It gives you p equal to, if you notice, dividing by 3 over 2 is multiplying by 2/3. So the 2 will go up. It will be 2k over 3 t to the power of 3 over 2 plus c. Now we need to find the c and also that k. How do we do that? We can use these two given values. Now we are given that p of 0 is 500. What does that mean? It means if you replace this t by 0, this p will be 500. Let's do that. So we say 500 equal to, when t becomes 0, this whole thing will become 0. So 500 equal to 0 plus c, and that gives you c equal to 500. We can now replace the c by 500. So we get p of t is 2k over 3 t to the power of 3 over 2 plus 500. Now we need to find the value of k. For that we use this condition, p of 1 equal to 600. When t equal to 1 is p equal to 600. Alright, let's do that. When t is replaced by 1, this p will be 600. Gives me 600 equal to 2k over 3 times 1. 1 to the power of 3 over 2 is 1 plus 500. Solve this for k. That's a simple equation for you to solve. Now try it on your own and see. I got k equal to 150. That means we can now take the value of k into the function for p, and that will be the proper p function. That will give me p equal to 2k, 2 times 150 over 3, t to the power of 3 over 2 plus 500. That means p of t equal to, that will give you 100 t to the power of 3 over 2 plus 500. Now what are we supposed to find? We need to find p of 7. Once you have this general equation of p as a function of t, we can find the value of p at any given time. So here, p of 7 therefore is 100 times 7 to the power of 3 over 2 plus 500, and that's equal to 2352. That has been a beautiful problem. In fact, calculus as a whole, if you notice how we are able to solve difficult problems using the method of calculus in a much simpler way. I hope you will appreciate the value of calculus. Alright, try some of these on your own and do the homework, and I'll see you next time for another lesson.